Hi, all, welcome to DevOps Factory and also Tritree Technologies. Who are not subscribed, please subscribe, and also who are watching in TritreeLearning.com. Please support us by joining learning.com website and also share it with your friends so that it will reach a lot of people where we are doing all the courses with very minimal prices. Okay, so we have done one section and we have talked about all the continuous delivery part, and also we have seen few of the very important things, how it worked in a traditional, like how we used to work in a traditional way, and what are the three important phases coming into this new era of continuous delivery. Okay, so we have already seen that in our chapter 1. Okay, so we'll try to cover what is Docker. So this is mostly like what the course what we are doing is revolves around the Docker, okay, Docker and Jenkins. So we'll try to cover it on what is Docker. So what are the things we'll try to cover? We'll see what is Docker. We'll see how to install a Docker, and we'll see how we can run Docker and what will be the Docker components. Okay, so let me write it down. Okay, so we'll see like what is Docker. Then we'll see installation of Docker, right? Then we'll see what are the components we will be having in the Docker, and we'll see Docker applications, what are the applications we'll have in the Docker, and we'll try to build some Docker images, and then we'll see Docker container states, what are the states it will have, and then we'll see basic networking of Docker. Then we'll try to cover volumes. Then we'll try to see how you can use the names in Docker, and also we'll try to do a Docker cleanup. And also we'll see Docker commands, like how we can run through the commands, and we'll see the overview of all these commands. Okay, so we'll try to cover all these stuff. Okay, so we'll try to make sure that this session will have all this information so that you guys can get exactly what is Docker. Okay, so if you want to move forward for this chapter, try to get your Docker installed on any of the machines. Okay, so the basic requirement for you to have a 4 GB RAM. Okay, so 4 GB RAM will work, or if you have whatever the operating system, so you can go with the Windows 10 or Windows 11, whatever you have. You can go with the Mac OS 10.15 plus, and also you can go with Ubuntu. Okay, so if you have 20.04 plus, you can go with any one of the Ubuntu versions as well, or you can go with any Linux platforms. It might be a CentOS, it might be any platform. It might be open source. Okay, so just try to get your machine ready so that you can work on that as well. So we'll see what is Docker. Okay, so proper definition of Docker. So Docker is one which is an open source project which is designed to help with application deployments. Okay, so it's an open source first thing. Okay, so Docker is an open source, and it is designed to help you with application deployment using software containers. So we are calling it as containers, that is software containers. We'll discuss what is software containers, but this is the project which is helping us to deploy all the software containers. Will have all your applications inside that container. So that is the approach. Like whatever, like this approach means running applications together with the complete environments. What I mean when I say complete environments, so complete environments are nothing but your files, your code libraries, and whatever the tools you're working on. Okay, so everything packaged into a single container. Okay, so therefore Docker. Okay, so uh, you might get an idea of something if you not at all know what is Docker. So now you might be comparing it. Okay, so we already have one of the concepts like this, that is called virtualization. Okay, so the same thing, like how you are allowing an application to be packaged into an image. Okay, so that can run like everywhere, like you can run that everywhere, right? So it is similar to the virtualization concept. So you can package your application and you can run that, you can package it as an image, and you can run that anywhere you wanted. Okay, so that is the major definition of your Docker. So now if I say virtualization, what is the major difference between a containerization platform and, or you can say, versus virtualization platform? Right, so the next question pops up is this one. Okay, so when we already have virtualization concept, why we need container, why we need a containerization platforms? So when we are saying like virtual machines, like, so the popular solutions are like VirtualBox, VMware, and Parallels. Okay, so a VM is nothing but which emulates your computer architecture and provides the functionality of your physical machine. Like it will be providing all your functionality as a physical computer. Okay, so for example, if I want to show you in a graphical representation, so for example, this is my server. Okay, so I'll say this is my server. Okay, so on top of that server there will be a host operating system which will be running on this server. Operating system. Okay, so there will be a host operating system running on top of this server. So if you want to go for any virtualization, you will have your hypervisor. Okay, so here you will have your hypervisor which will be running on top of your host operating system. So then if you want to create any VMs, for example, if I want to create a VM, so I want to create an image, so I'll say image1. Here I'll have all my applications, all my libraries, but the main important thing is there will be an operating system, guest operating system running on top of the hypervisor in every virtual machine image. For example, if I want to launch one more VM, okay, so this VM also will have a guest operating system with its libraries and application. Okay, and I'll call it as image2. Okay, so in this way, if I am running two virtual machines images, it will have its own guest operating system running inside that virtual machine. Okay, so each application whichever is launched will have a separate image with all its dependencies like libraries or all the required dependencies with respect to your guest operating system. So images which are when the images are running through your hypervisor. So hypervisor is nothing but which emulates your physical computer architecture. Nothing but your architecture has been emulated, and it will be creating all your virtual machine images with respect to the guest operating system. Okay, so when you are talking about these kind of infrastructure or parts like the method of deployment, okay, so there are so many tools like for example, if you take Vagrant, okay, so, and also if you have a dedicated to deployment or testing environments, virtualization is having three main drawbacks when you have when you are looking into this architecture. So what are the three main drawbacks it has is the performance. Okay, so when I say it has a low performance, right, because VM emulates a whole computer architecture. So whatever you are seeing in your physical machine, it is emulating everything as your physical machine. Okay, so to run this guest operating system, it just emulates your whole computer architecture, and also there will be a significant overhead associated with it. Okay, so whenever you are running in each operation, okay, so whenever you run a simple operation within the VM, okay, so it has to emulate all your operating system. Then high resource consumption. What do you mean by high resource consumption? Because your machine, like it emulates, or the emulation, whatever we are talking about, right? So the emulation requires a lot of resources and has to be done separately for each application. So whatever the application you are running, it will, like I said, it is emulating all your computer architecture, and also it requires that it requires a lot of resources to achieve that particular solution. Okay, so this is why on a standard desktop machine you can run only few applications simultaneously. You cannot run more than 2 or 3 applications simultaneously because your resources might not be enough. And also large image size. What do you mean by large image size? Because every image, like I said, every image is having a guest operating system. Okay, so when you are importing your operating system, nothing but you will be having full compatible operating system deployed into that image. So the image is a very big, like like operating system image will be very big. It might be in GBs, it might be in 4 GB, 1 GB. Like if you're going for the full operating system model, then it will be 6 GB also, 8 GB also. Okay, so it is a large image size component. Okay, so that is one of the drawbacks of the VMs, we can say. So how the concept of containerization gives you a different solution. Okay, so what exactly difference between this architecture and the dockerized or containerized architecture? So when I'm talking about containerization, if I do containerization, okay, so when I'm talking about containerization, so how it will be, you will be having your server again. On server again, you will have your host operating system, right? So on top of this, if you are having a hypervisor, you are saying it as a VM. But if you are going for any containerized platform, and I said Docker is a project which is a famous or which is extensively used containerized platform. So you should have a Docker engine on top of your host operating system. Okay, so this is my Docker engine, and if I want to build an image on top of this Docker engine, I will have my binaries and libraries, and I'll have my application, and I'll package it as an image, right? So here I'm eliminating the guest operating system. Okay, so here I'll have my application too, and I'll have my image too. Okay, so this is how your containerized platform looks like when you are comparing with your VM. So each application is delivered together with its dependencies, but without the operating system. That is very important, a very important difference between these two. Okay, so whatever the application you are delivering, like it is delivered together with all your dependencies like your binaries, libraries, everything, without your operating system. And also applications interface directly with the host operating system, so there is no additional layer for the guest operating system. So this results a better performance, and you can see there is no wastage of resources. Okay, so there won't be any resource wastages, right? And also if you want to ship your images, these are very smaller in size because you don't see your operating system inside this. Okay, so it is very easy for you to ship these images because these are smaller in size. Okay, so the reason, because people are more aligned towards Docker these days, or you can say containerized platforms these days. Okay, so what is the need of Docker right now? Why when you compare these two things, you have got like what are the drawbacks and what are the things containerized platform is coming over. Okay, so or overcoming things. Okay, so when you are saying like what is the need for the Docker, why we need Docker now? Okay, why it is very important to use the Docker, what are the problems it is solving, and what are the problems it is solving with respect to the traditional software delivery. Okay, so I'll try to see few of the points like why it is very important and how it is solving the problems when we are talking about traditional way of doing. Okay, so environment, like when we are talking about any environment, Okay, so installing and running a software is always a complex thing. Okay, so whenever you want to install any software, so it will have all its complexities to get installed, because you need to make a decision on uh, what kind of operating system you require, and what all the resources you need, and what all the libraries you need, what all the binaries you need, what are the services it required, and what all the permissions it should have, and what all the dependent softwares it has, and uh, everything. When you're talking about an application, it has all its dependencies, and all the application dependencies it is depending on. So you need to figure out all these things, and you need to decide like how you can go ahead forward, because when you need to know how to install it. Then you may, like, there may be some conflicting dependencies, like what do you do with those conflicts, and what is your software need an upgrade of a library, or but the other resources you cannot upgrade. Okay, so all these issues are coming up, will be there when you have to install a software. Okay, so all these complexities will be moving around it, right? So it is always important that whenever you are doing a solution, okay, so it should be always be balanced, like between your application, your services, and what kind of operating system you are using, right? And also one more problem you might see with the environment complexity is that often it requires a specialist, right? Look, for example, if there is any operating sorry, if there any software, okay, so if someone wants to install it, you might need an SME for that. So you need a specialist to go and deploy it. For example, if I want to deploy, or if I want to set up MySQL or an open database connectivity, okay, so ODBC, so I definitely need an expert. Okay, so a database expert, or a person who is having a good knowledge about that. Otherwise, a person which who have normal technical knowledge cannot deploy this. Okay, and also you cannot deliver the targets, or you cannot deliver whatever is promised to the client. So all these problems will come up when you are talking about such environments. Okay, so how Docker is overcoming all this stuff. Okay, so all this stuff will be packaged into an image. Okay, so you might not be worrying about a SME who is going to go come and create all this stuff for you and all that, right? So when something is packaged into an image, you can directly pick that image and you can use that image, so that all these library dependencies, services, permissions, whatever the software dependencies you have, the resource dependencies you have, all these dependencies has been resolved within the Docker. Okay, so that is very important. Whenever we are picking the Docker, this is one of the reasons. And also, like, how you organizing your applications is very important when you are talking about Docker. And also portability. Okay, so you can write once and run anywhere. Like, you can deploy that image anywhere. You can go for that image into your any environments, right? So the mostly the Docker moves the concept of portability on one more higher level. Okay, so if the Docker version is compatible, the shipped software works correctly regardless of the programming language, operating system, or environment configuration. Okay, so it is always a portable option that you have when you are going for the Dockers. Okay, and also what are the few other containerized technology? We are mostly talking about Docker, right? So, but what are the other containerized platforms in the market? Okay, so we have LXC, that is Linux containerized containers. Okay, so LXC system is the one which is open source. So next one is your Windows Server containers. Okay, so you have Windows Server containers, you have OpenVZ, you have other platforms. There are so many platforms. Okay, so which also provides you the containerization technologies. Okay, so right now Linux, Red Hat is also providing you with something called Podman, which is becoming a very popular containerized platform project. Okay, so Podman is the one which if you have Red Hat 8 or 9, it comes packaged with your Red Hat. Okay, so all these alternatives are available in the market. Okay, so you guys can go and explore on them if you want to get into more on how things works with other platforms as well. Okay, so but here in this session we'll be talking more on Dockers. Okay, so we'll see how to get the Docker done. Okay, so what are the prerequisites to install your Docker? Okay, so to install your Docker, like I said, if you are going for the Linux one, go for 64-bit architecture. You need to have your kernel version 3.10 on later. Or if you're going with the Windows, you should have with your 64-bit Windows 10 or 11, the Hyper-V package should be enabled. Okay, so when you are going for the Windows, so Hyper-V should be enabled. Okay, so Linux, you can go with any Linux with kernel 3.10 or later, if it is your Linux box. Okay, so you can install your Linux on the local machine in the sense if you have Windows machine, you guys can go and install that using Docker. Okay, Docker on Windows, that is your Docker desktop. If I click on Docker, okay, so Docker desktop for Windows, you guys can see this. I've already installed that in my machine. If I go open and show you that, okay, so this is my Docker desktop. Okay, so you guys can have your Docker desktop installed. Like it's just an exe file. You guys can get that exe file and you can run if you want to require this. Okay, so it's a simple setup. Okay, so simple thing. Okay, so it says Docker is starting. Okay, so now if you see all the containers and you can see all the images, what are the images I have, what are the volumes I have, what are the development environment I have created. Okay, so I have not created anything. Okay, so this is how it looks like. Okay, so this is your desktop, Docker desktop looks like. If you are working on Windows, you guys can go ahead and do that. Okay, so but if you are working on Ubuntu, okay, so again you guys can go here and Docker on Ubuntu. Okay, so install Docker engine on Ubuntu, then you can go here, you can see all this stuff. Okay, so operating system requirements is clearly given here. You guys can uninstall the older versions if you have any, or else you can go with the setup the repository. I already have my Ubuntu box. Let me open that box, find and enter. Okay, this is my Ubuntu box. Let me open my terminal. Okay, let me check if my Docker is available. Okay, Docker not found, so I don't have Docker installed on this machine. Okay, so now I'll just show you like how we can do that. I'll just copy the commands here. apt get update sudo is not required for me, but anyway it will work even if I'm a root. Okay, then you need to go with these installations, that is CA certificates, curl GNUPG and LSB hyphen release. Okay, I'll say yes. Okay, so add official GPG key, it says. Okay, so you guys can go and add official GPG key. You can create a directory, or you can directly go with that, no issues, but yeah, we'll do it in an organized way. Okay, then I'll get this GPG key. Got it. Okay, use the following command to set up the repository. Okay, so we need to set up the repository. Okay, repository, I've done the repository setup. Now you need to install the Docker engine. Okay, so I'll just do apt get install So update will just update whatever the repositories we have added. Then we can go with it apt get install docker engine and also CLI with container.io and also Docker Compose. Okay, so it is also having Docker Compose. And if you want to install a specific version, you can go with the specific version as well. I'm going with the latest version. I'm not going to go for a specific version as such. Okay, so then we can go and verify that Docker engine is installed correctly by running this hello world. Let me copy this. Okay, let me paste this here. Okay, so it says unable to find the image locally, so that it will go to the Docker hub and it will just gets that image. Okay, so now if I say Docker ps, okay, so it's not there. I'll say Docker -version. Okay, so I got the Docker version with 20.10.17 with build 100C701. Okay, so here we have installed our Docker, and if you want to enable other users to use this Docker, you can add those users names. Okay, so for example, if I have any user, I don't have any user as such, but if I say user add Tri-Tree Technologies, add user. Okay, so I'll give password. Okay, so if I want to give the Docker access, okay, so to any user, I can do user mod. Okay, so I'll say user mod -a-g and I'll say Docker with Tri-Tree Technologies. Okay, so this is how you can give the access to the user. Okay, so you can log out and you can log in with the Tri-Tree Technologies user. You can go ahead and see that. Okay, so how you test your installation, like I said, you can get the information or else you can get the version. You can go with the Docker info. Okay, so Docker info will show you all the information about what is there and how successfully you have installed. Okay, so you can directly go and check with this command Docker info, or else you can go with the Docker. Sorry, you can go with the Docker -- version or Docker info. Okay, so Docker info just shows everything about how many containers you have, how many stopped, how many images you have, what is a version of that, and what are the logging drivers you are using, C group drivers, what you are using, what is the kernel version, architecture, OS type, total memory, CPUs, everything it is showing. Okay, so you guys can go and check with the Docker info. Okay, so this is how you can install your Docker. Okay, so I've already shown you like how you can run the Docker. So if you want to run the Docker, the command is docker run. I'll say hello-world. Oops. Sorry. Okay, so if you see Docker run hello-world. Okay, so it says to try something more ambitious, you can do Docker run -it. Okay, so it says, but here it says like hello from Docker. This message shows that your installation appears to be working correctly. Okay, so it just confirms that yeah, your information is or your installation is working properly. And also whenever you ran the Docker client, right, with the run command, okay, so this is where you are running, or the Docker client contacted the Docker daemon. Okay, so whenever we are doing a run, let me go back to my whiteboard. Right, so whenever we are doing a run command, okay, so what it does, okay, so the Docker client goes and contacts with the Docker daemon. Okay, and it asks to create a container from the image called hello world. Right, because what is the command we have run? We have run docker run hello world. right? So this command, okay, so this is the run command. So this run command goes and talks with the Docker daemon. And what it is asking the Docker daemon? It is asking Docker daemon to create a hello world, or it is asking to find the image. Okay, so it is going and asking to find the image hello world. So what Docker daemon has does, Docker daemon checked whether it contained the hello world or not locally, right? First what it checked locally, right? And it is not available locally. So what it does, it just requested the hello world image for the from the remote Docker Hub registry. Okay, so where it went locally, it searched, it didn't got the hello world, then it went to the Docker Hub, it got that. Okay, so it just checked whether this Docker Hub is having hello world or not. So Docker Hub registry, okay, so this is the registry where it will have the hello world image. Okay, so from there your Docker daemon, what it does, it just pulled that image. Okay, so it just pulled the image into your local, right? Then it has created a new container. So out of hello world image, it has created a new container. Okay, so from hello world image, it has created a new container. Then Docker daemon streamed this output to the Docker client, right? Saying that, okay, so this is what happened. Okay, so what happened exactly? Okay, so this is your Docker client. So you are sitting here, you are requesting this to the Docker client. Then what Docker client does, it will go and ask your Docker daemon, right? Then what happened? So it checked locally, then it went to your Docker registry. Okay, so this is on a hub server. Okay, this is entirely out of your network, nothing but it is on the internet, right? So this is whatever this happened, this is on your local machine. So this is happening on your local machine, right? Then from Docker registry you got the image. Okay, so I'll say this is the second step, this is your third step, this is your fourth step. Okay, so Docker daemon got it. Okay, so got it, this image got to the Docker daemon, then it is informing to the client saying that we got it, then it just posted you. Okay, so saying that this image has been containerized as a new container. Okay, so this is how Docker run command execution works. If you see here, so unable to find image locally, it says. Okay, so if you don't have image locally, it just searches to the, it goes to the Docker Hub and then it searches that image. Then it will say that if there is an image, it's just showing you that this message is shows that your installation appears to be working correctly. Okay, so if I say Docker ps-a, okay, so if you see here, these are the images which are available. Okay, so we have pulled 2 times. Okay, so it got in and it got out. Okay, so there's no running containers, but it has created a container and it has exited out of that. Okay, so this is how you can see, and how it works I just shown you in a graphical representation. When you have run the command docker run, so this is what happens in the background. Okay, so this is very important, like why you require a Docker daemon, how it works. Okay, so whatever you push in the Docker, it goes and asks your Docker daemon whether it is having that proper image in your local machine. If it is not, it will go to hub, it will fetch those images, then it will give you to the, then it will then Docker daemon give it to the Docker client, nothing but the one who is requesting, it might be you. Okay, so the next thing is we talk about Docker components. Okay, We'll talk about Docker components. So Docker is actually it is like an ecosystem. Okay, so that includes number of components. So we'll describe all the components. Okay, so we'll see how these components work, or we'll see mostly on a Docker client server architecture, how your client and server architecture looks like. Okay, so whenever I'm talking about Docker client and server, okay, so how that looks like. So now I can say that Docker client is going to hit your Docker daemon, right? So here you will have all your images and containers. Okay, so I'll mark it as my oops. Okay, I'll mark it as my Docker host. Okay, so this is my Docker daemon. Then all my images and containers will be running out here. Right, so it might be my container A, container B, container C, okay, container D, and I'll have my images like images A, images B, C, D. Okay, so these are all images, these are all containers. Okay, so where my Docker daemon goes and talks, and also how I communicate with this Docker daemon. If I want to see what are the images I have, what are the containers I have, I can do with the REST API. Okay, so I can do REST API calls. Okay, so this is how I can go and talk. Okay, so Docker daemon is nothing but the run, which is the daemon running in the background. Okay, so Docker daemon is the kind of server. Okay, so which will be running in the background, and client is running as your command tool. Okay, so whatever the commands we are running, okay, so your client is running as a command tool, and your Docker REST API is the one where you can call all your information. Okay, so you can call all the information. For example, installing Docker means installing all the components so that the Docker daemon runs on your computer all the time as a service. Okay, so how it is running in your machine, it is running as a service. Whenever we are installing a Docker, so it is installing all these components. Okay, so if for example in hello world, right, so we used Docker client to interact with the Docker daemon, but we could do exactly the same thing using REST API. Okay, so in the case of hello world example, we connected to the local Docker daemon, but we could use the same client to interact with the Docker daemon running on the remote machines. Okay, so how you can do that? For example, if I am going with an option called -h with the server name run hello world, I can go and connect with that remote host. Nothing but I'll just give you an example of, I can say Docker -h with IP address of that machine and with port number, and if I say run hello world, okay, so it is running on your remote machine. Okay, so we could use the same client to interact with the Docker daemon running on the remote machines. Okay, so this is how you can do it. Okay, so we'll do that more often. Okay, so if required. Okay, so but this is how you can go and connect to the remote servers. If someone asks you in the interview, you can give them this command. Okay, so what do you mean by Docker images? Okay, so we have talked about components. Now in components we have talked about images and containers. Okay, so what exactly this Docker image and containers? Okay, so what are Docker images and containers? Image is nothing but a stateless building block. Okay, so it's a stateless building block in the Docker world. Okay, so you can think of an image as a collection of all the files necessary to run your application. Okay, so whatever the application you are running, okay, so it is nothing but collection of all the files, and also together with the recipe of how to run it. Okay, so how you run that application is also one of the packages or the things that we call or pack in an image. Okay, so image is nothing but a stateless building block. Okay, so that is the reason why we call it as a stateless building block. And also you can send it, or you can send this image over the network, or you can send it to store or whatever you wanted. Okay, so you can name it, you can version it, you can save it as a file, and you can move it around through the network, I say, like I said. Okay, so that is how the image is called as. Okay, so images are laid like nothing but you will have to build an image on top of another image. So when I'm talking about a Docker image, it is always having a layers of images which will combinedly create one image. Okay, so for example, if I have a kernel, okay, in my image I will have my kernel, then on that I will have my base image, that might be Ubuntu, right? On top I will have my image of maybe if I want to add Git, I will add image of Git, and then if I want to add any Java, okay, so I will add Java JDK, right? Then I will make it as a container. Okay, so these are all the this is the structure of your Docker images. Okay, so if you talk about the layered structures, okay, so whenever you download something, okay, so for example, if you want to pull some image, it will be pulled as layers. Okay, so I'll show you that. Okay, so whenever we pull some images, you can see that it will be coming in the layers, nothing but your container or the image will have layered of images to make one image. Okay, so every time when you want to create an image, there will be a base image. Most of the cases that represents your operating system. Okay, so here in our base image in this diagram, I'm showing you it as a Ubuntu. Okay, so we have to build our images on top of existing base images. Okay, so most of the time we'll be building our images on the same way. Okay, so you can use any base image to build your image. Okay, so it technically possible to create your own base images, but it's rarely required. Okay, whenever you are into most development environments where you are creating everything from scratch. Okay, and also the best example would be your mobiles. Okay, so if you want to wrap that on a customized base image, you can do that. Okay, but most of the time when I'm talking about the IT, like in our infrastructures, we are not going to do that. We are not going to create any base images, but most of the time we'll be building images on top of existing base images only. Okay, so here in this example, like I have taken Ubuntu as a base image, which provides all the capabilities of your Ubuntu operating system, and we are adding Git image, which adds your Git toolkit. Okay, so and also we are adding JDK, so where it will give your Java development kit. Okay, so whatever the Java kind related things, okay, you can run on that image. That is what that means. Okay, finally we on the top there is a container which is created from the add JDK image. Okay, so these containers are able, like for example, like if you want to download a Java project from GitHub repository, and you can compile it with the jar files. Okay, so this is how you can do it. And also, like if you want to run any image, okay, so if you want to add Python, or if you want to run some Python coding, or if you want to work on some Python, you can do something like this. Okay, so you can do the layers of images like kernel, then you can add your base image. So I'll add my Ubuntu as a base image. On top of that, you can go with your Python. Okay, so I'll just say add Python image, and then it will create my container. Okay, so now what I'm doing, I'm packaging my application as a container. Okay, so in the same way, like if I want to use an existing application or use an existing application which is packaged as a image, how I can use that? Okay, so for example, if I run my Docker applications, right, so there will be a lot of applications which are provided in the form of Docker images. Okay, so that you can download from the internet and you can work on them. Like if you know the image name, it would be easy for you to get that image, or else you can go and search for that image, whether like is that image existing or not, like how that image is been named. Okay, so that is also we can go and explore that on your Docker hub, or else you can directly explore that from your local Docker machine. Okay, so how we can do that? Just let me go back to my Ubuntu. So now I can do a search of an application. For example, if I want to check on the MongoDB, okay, so how I do, I'll say Docker search Mongo. Okay, so it might give you a lot of images. Okay, so if you see here, I can see Mongo Express, Bitnami, MongoDB, Pekona, and Bitnami, Pekona, Cope, IBM Com, Rancher, MongoDB, Rapid Food. Okay, so if you see here, there are many images. Okay, so which have been popped up when I'm doing a search of Mongo. Okay, so now the interesting thing is how do we choose the best image, how we can choose the best image out of this. Okay, so usually the most appealing one is the one without any prefix. Okay, so when you see if there is no prefix, since it means that it's an official Docker hub image. Okay, so this is the one which is a official Docker hub image. And how you can see that? Here if you see, it says official okay, official okay. Okay, so Mongo Express and Mongo, these two are the official images, and you can confirm that from here. And also if you have no prefix, okay, so there is no prefix for these two. Okay, so that is nothing but these are the images. Okay, so from the Docker hub itself, nothing but these are the official images and are maintained by the Docker hub or a Docker with stable and it shows that it is stable and it is maintained by the Docker hub. Okay, so these images with prefixes are unofficial. Okay, so whatever the images which are shown here, right, these are all unofficial images. These are maintained or managed by the open source projects. Okay, so Bitnami is one which is an open source project which is maintained, which is maintaining this image. Okay, so that is the difference, and that is how you can choose like to go with which image. Okay, so there is always like you need to find out like which suits your requirement and which suits your dependencies as well. Okay, so sometimes it might not that like official, you might not require an official image, but you might need some added things to that. Okay, so if you see here a Prometheus exporter for MongoDB, okay, so if you are looking for a Prometheus exporter with MongoDB for MongoDB, you can go for this image. Okay, so it totally depends on your requirement. Okay, but it is always good that if you are going with an official image. So how you build these images? Okay, so that is very important, like how you are gonna build all these images. So we have talked a lot about images, layered images, how it looks like on a graphical representation, and how you search and how you pull them. Okay, so how you build all these Docker images. Okay, so building the Docker image is like you have different methods. Okay, so you can build Docker images using two different methods. I can see one is using Docker commit. Docker commit command is the one where you can use to create your Docker image, and also a Docker file automated build. Okay, so I'll show that both methods, like how you can build your Docker images. So how we can do with one method is Docker commit. Okay, so let's start with an example. Okay, so we'll try to prepare an image with the Git and JDK, which we have shown in the diagram. Okay, so previously I've shown you that, right? So we'll try to build this. Okay, so how we gonna do that? Okay, so we'll try to do with the Docker commit. Okay, so now what I'll do is I'll say Docker run -i -t with, I'll go with the base image as Ubuntu, and I'll go with the version, you can go with 20 dot, oopsie, 1 second, 20.04. Then I'll say bin bash, okay, and I'll do enter. Okay, so it's just checking locally, it's not there, then it will go to this my Docker domain, going to the Docker hub, then fetching that image. Okay, so if you see here, now I got the image. Okay, so it says like I have got the image. Okay, so nothing but we have pulled the Ubuntu image. Okay, so and we have run it as a container, and then we called the bin bash command. Okay, so that we can move in a interact way. Okay, so you should like now you are seeing the terminal. Okay, so what is the terminal you are seeing? Root @b7 bb63c4 fb77. Okay, so this is a Ubuntu box, so we are into a Ubuntu container. Okay, we are not in our Ubuntu prompt. Okay, so this is my localhost prompt, but we are inside of the image, nothing but we are inside of the container now. Okay, so now what we can do is, what I'll do is I will say apt-get update. Oops, update. Okay, so I'm just updating this Ubuntu image, Ubuntu container. Okay, so then we'll try to install the Git inside this. Okay, so we'll try to install Git toolkit. So that is our requirement. So if I go back again, okay, so we have our base image now. Okay, on top of that we need to add Git. Okay, so what I will do, I'll just go back here. Okay, so now what I will do is I will install Git apt-get install -y git. Okay, so it's just getting me the Git toolkit. Okay, so after installing Git toolkit, we'll see whether we got it or not. It should be having in your user bin Git. I think so. Okay, so we'll wait for this to get downloaded. Okay, so now I've got Git inside this container. I'll say which Git. Okay, so Git is in user bin Git. Okay, so now what I'll do, I will do exit. Okay, so now I'm coming out of this box or container. Okay, so now how you check what has changed in this container, what is the difference? Okay, so now I'll say docker diff with this ID. Okay, so whatever the ID we have. Okay, so I'll just copy it, I'll paste this, I'll do enter. So these are all the changes which we have done. Okay, so these are all the things. Okay, so if I go with the diff, okay, so it's just showing all the things, what the changes we have done. Okay, so now I want to commit this. Okay, so nothing but like I want to create my container. Okay, so with all the files which I have changed. So what I can do, I can say docker commit. Okay, and I'll give this ID identifier, this docker identifier, then I'll give any name. So what I'll do, I'll say Ubuntu Git. Okay, so I'm having Ubuntu with Git here. Then I'll say enter. Invalid reference format, it has to be lowercase. Oops. What happened? Okay, even Git I have given it in Okay, now I said commit. Okay, so now if you see here, this is my image. Okay, so this is my new image. If I go and check with the images, I'll say Docker images. Sorry for that. Okay, so Docker images. Okay, so here Ubuntu underscore git latest. This is my image ID. Okay, so my image is now in my images box. Okay, so now if I go to Docker again, if I say run -it, I'll say Ubuntu underscore git and I'll say /bin/bash. Right, I'll say which git. It is there. Okay, so now I have packaged it as a image. Okay, so this is how you can do with the Docker commit. Okay, so how you build your Docker image using Docker commit, this is the one way. Okay, so the next other way is your Docker file. Okay, so creating each Docker image manually with the commit command could be a huge thing. Okay, so it's a tedious process. Okay, so especially when you're building your automation, whenever you are doing your continuous delivery process. Okay, so the Docker commit will not work there. Okay, so it is always important like how you build your or build in images with the Docker file. Okay, so let's try to do that with a Docker file. So I'll just come out of this box. Okay, so now we'll try to create a directory. Okay, so I will create a file with a Docker file. Okay, so let me create something called mkdir docker images cd docker images. So now I'll try to create, I'll just do touch first. Okay, so touch, I'll say docker file. Okay, so ls-lrd, I have my Docker file which is empty. Okay, so now I'll go to my Docker file. Okay, so what I can do here. Okay, so what are the things I can write here. Okay, now I'll say from. Okay, so we need to have our base image, right? So base image I'll go with again Ubuntu and I'll go with 20.04. This is my base image. Then I'll say run, I'll do apt-get, I'll say update, whatever we have done, right? So then I'll do double ampersandage, then I'll say apt-get install. We'll go with the next example. Okay, so we'll go with the Python. Okay, so now I'll say -y, I'll say Python. Okay, then I will save this file. Right, so if I say cat docker file, okay, so I'm getting my base image from Ubuntu and I'm running apt-get update and also I'm installing apt-get install -y Python. Okay, so now I'll try to build this. Okay, so how I can build this? Now I need to run something with docker space build. Okay, so docker space build -t, I'll say Ubuntu underscore Python. Okay, so this is my image and I'll see dot. Okay, so if you see here, it's just building the base image and it is running the update, it is running the Python, it is getting all the Python packages. Okay, so now it just shows that it got built the image. Okay, so now I'll say clear, then I'll say docker images. Okay, so if you see here, Ubuntu underscore Python is also there. Okay, so we have both Ubuntu base images and we have only one Ubuntu image here. Okay, so because out of this image is just creating all the base images. Okay, so like if you are using a base image for 50 images also, you will have only one Ubuntu image on your machine. You cannot say 50 Ubuntu images. Okay, so that is not a case. Okay, so here we have built our image. Okay, so what are the things we have used whenever I go to Docker file? If you see here, we are using from. Okay, so from is nothing but which defines an image on top of which the new image will be built. Okay, so nothing but on top of Ubuntu we are building other images, right? and also run. Run specifies the command to run inside the container. Okay, so inside the container we are specifying that to run apt get update and also apt get install Python. And also the mostly widely used other instructions in container are copy command, add command, okay, entry point, which defines which application should be run in the executable containers. Okay, so all these examples you guys can go and watch in the docker.com if possible. Go to documents, you'll see all that stuff. Okay, so now what we'll do is we'll try to create something like complete Docker application. Okay, so now you guys know like a bit of information of how to build an image. Okay, so how to build an image with a Docker commit, or how you can do it with the build Docker build command or the Docker files, right? So now we'll try to do a complete application. Okay, so now what I'll do, I'll come out of these, or I'll just go back. Okay, so what I'll do, I'll create one file. Okay, so I'll just create one Python file. I'll say hello.py. Okay, so then I'll just say print hi DevOps factory subscribers. Okay, and okay, so now what we'll do, we'll make this as a source code of our application. Okay, so now we'll try to prepare our application. Okay, so which base image, like we will go with our base image, then we'll install Python, then we'll include that hello.py in that, then we'll try to start the application. Okay, so how we can do that? Okay, so in the Docker file what we have created, okay, so I'll just try to do the same. Okay, so I'll go with insert mode. Okay, so now if you see from Ubuntu 20.04 we are running apt update, and also we are going with the apt get install -by Python. Now I copy, right, what I'm going to copy, hello.py. okay, so where is that file? It is in my working directory now. Then I'll give a entry point. Okay, so I'll give entry point as, so what it will be, my command will be Python, right? Then I will run this hello.py. Right, so we are running Python hello.py. Okay, so how you build this image again? I'll go back. Okay, I'll say cat Docker file to check if everything is fine, and also I have hello.py here. I do ls. Okay, so hello.py is also there. So now what I'll do, I'll say docker build -t. I'll say hello world with Python. Okay, then I do enter. Okay, so now if I say docker images, okay, so I have my hello world underscore Python available here, right? So we have built our image. Okay, so if you want to run this application, okay, so if you want to run this application, how you do that? You'll be doing docker run hw underscore Python. Okay, so what is the output I got? I got hello DevOps factory subscribers. Okay, so I just running the application. Okay, so whatever the application we are running, it's just showing you that, nothing but it is executing that, and it is showing up here. Okay, so here we have an image with the Python interpreter, which is already exists in the Docker services. Okay, so how you can do with the environment variables, how you do environment, like what is the importance of environment variables. Whenever like we have run our first Docker application. Okay, so but if you need to execute of, like if you need execution of the application, okay, so or if it is depending on any conditions, okay, so it should meet this condition to have this, or it should meet this condition to run this. Okay, so if you're running something on the production servers, for example, like if you would like to print something hello to the logs, or not to the console, or we may want to have different dependent services whenever we are doing the testing, or whenever we are on the production phase, you want to show up a different service. Okay, so how you gonna do this, or how you gonna prepare a separate Docker file for each case. So we have a different method of using environment variables for such cases. Okay, so let's do the same whatever we have done, right? So I'll go to my hello world again. We'll go and see how that can be done. Okay, so now what I'll do, I'll go to vi hello.py. Then we can say insert mode, I'll say import OS. Okay, so then I'll say print hello world, or print hello developers, or hello DevOps factory subscribers from, I'll say percentage s exclamatory I'll say percentage OS dot environment. I'll give some name. Okay, okay, OS dot environ. Okay, it looks good. Okay, I'm just saving this. Okay, now what I'll do, I'll say docker build -t hello world Python. I'll say hw_py now. Okay, so okay, so now if I run, okay, so if I say docker run, I'll say -e and I'll give name, because if you remember, like in .py I have mentioned that I'll be passing the name. Okay, so name of the OS, whatever it might be. Okay, so I'll say something like Tritree Technologies, and I'll say hw_py. Okay, so it is just saying like hello DevOps factory subscribers from Tritree Technologies. So if I want to mention an other environment, for example, if I say testing, okay, so it is just says testing. If I want to pass anything from the production, okay, so I can give this name. Okay, so environment name, okay, env name is nothing but your environment variable. Okay, so you can alternatively define an environment variable value in Docker file. Okay, so whatever it might be. Okay, so you can give env name. Okay, so you can give whatever the definition you wanted. Okay, so now you can run the command without specifying the option also, -e option also. Like for example, if I say docker build -t say default. Okay, so now if I say docker run SWI, oops. Okay, so here again without hyphen e it is just throwing the error. Okay, so because we need to use the option hyphen e to give the environment variable name. So what I'll do is I'll go to my docker file. Okay, so what we can do is set mode, we can say env name, I can give it as type technologies. Okay, so now again I'll try to build an image, then we'll try to run without the hyphen e option. Okay, so we are passing that environment variable name through docker file. Okay, so you can do that also, like alternatively you can do that, or else you can go with the hyphen e. Okay, if you have not given that in the environment variables, because this image hw_py should have hyphen e option. If I am not going to give this hyphen e option, it will throw me an error saying that you have not passed any environment variables. Okay, so key error is name, it says. Okay, so there is, you have not passed any name, but if I am passing any name, it just gives me the output. Okay, so this is how you can build, this is how you can run your applications. Okay, so this is entire an example, simple example where you guys can do a lot of R&D on that. Okay, so this is how you can check on that. So now we'll see Docker container states. So what are the states we have in the Docker container and what are the things we have in the Docker container. Okay, so for example, every applications or whatever applications we are running, so we are supposed to do some work, or like we are doing like it should do something and it should stop. Okay, so we are not continuously running it. Okay, so we have printed hello DevOps factory subscribers, and we have entered with the hyphen e option. Okay, so that is how we are doing. But to run a container in the background, okay, so we can use something called detach. So when you are doing a detach option, your container will be running in the background. For example, if I say docker ps, so I'm not seeing anything. Okay, so no images are running here, because whatever we have run till now, so it is running and it is coming out. Okay, so it just exited out of that. So now we want something which should run in the background. Okay, so what I'll do something called docker run hyphen d. Hyphen d is nothing but it is running in a detached mode. Okay, so I'll say Ubuntu and I'll say 20.04. Okay, so now if I say docker ps, okay, if you see here, the status is up from last 2 seconds. Okay, so nothing but the command ps. Okay, so prints all the containers that are running. Okay, so that are in a running state. Okay, so what about the exited containers or the old containers which we ran? So if you want to see that, you can also run a command docker ps hyphen a. So docker ps hyphen a is showing all the containers which we have ran 1 hour ago, 29 minutes ago, 2 minutes ago. Okay, so this got exited, all these are exited, right? So these are all exited, and this is the one which is running from last 28 seconds. Okay, so what are the states? So now we have seen exited state and we have seen something in a running state. So what are the things we have, what are the states we can have in the Docker? Okay, so now if I say run, right, it went into the running state. So from running state we will also have something called pause state. Okay, you can move your Docker into paused state also, or else you can move into running by unpausing it. Okay, you can do unpause, or else you can stop, or you can kill the container. Okay, so nothing but it will be, when you do stop, it will go into the stopped state. When you kill, it will be exited, right? And also you can start it again to move into the running state, right? And also something which is there is restarting, right? So whenever you are restarting, it will go into the stop state, then it will go into the running state. Sorry, restart. Okay, so whenever we do restart, it will go into stop state, and also it will go into the running state. Okay, so you can create, and also you can remove. Okay, nothing but you can create your image, you can remove the image as well. Okay, so pausing Docker containers is very rare. Okay, so most of the times it's not done by freezing the process. Okay, so you can do sorry, it's done by freezing the process using something called SIG stop. Okay, so SIG stop signal. Okay, so you can do with the SIG stop signal, and restarting is the temporary state. When the container is in restart option, when you do it is in a restart option, it will go into stop state, and then it will come into the start state. Then if you want to stop any container, you can directly do that using Docker stop and the identifier. Okay, so whatever the identifier of the Docker. Okay, so for example, if I go back here, okay, so this is my identifier, and I'll say Docker ps. Okay, so now I'll say Docker stop ps. Okay, so nothing is there. If I say ps-a, it will be in a exited state. Okay, so because we have moved it into the exited state, because nothing is running in the background. Okay, so now if I want to move it back, I can move it back. Okay, so this is how you can do. Okay, so this is how you can work on the states of your Docker. Okay, so you can do pause, you can stop, exit, you can do restart, and you can move into the running state again. So Docker is a sorry, in the Docker you will have 4 states. Okay, so running, pause, so restarting, and stopped and exited. Okay, so any one of these state is stopped or exited. So what are the running services? Okay, so when you are talking about Docker networking is very important. Okay, so how you see what all the services are running, okay, so into the Docker, and how you check the networking of the Docker, like how you check the logs of the Docker, how you check the ports of the Docker, how container networking works. Okay, so we'll try to cover all the container networking now. Okay, so we'll move to container networking, or you can say Docker networking.